Hello students, welcome once again to another section. Now in this section we are going to look at the center of mass in calculus. So we should find the center of mass for the region bounded by y equal to 4 minus s squared. That is in the first quadrant. So first let's do a quick sketch on that. So sketching that with the center of mass, then we can have, so this is if this is a Cartesian, then which means that we have x here, we have 1, then we have, let's say 2, let's say we have 1 here, we can have 4 here, say 3, 2, and let's say we have 1 here, and this is 1, this is basically the origin. So you realize that sketching y here equal to 4 minus s squared, we are just going to get the curve as that, right? We are going to get the curve as this. Then we will have our center of mass somewhere in between here, right? In between that. So first what we have to do is to calculate the area of this region, right? So we are going to calculate the area of this region, and the area of the region here is given by, so the area here is given by, the integral of the s part. So this is x and this y. You realize that s started from a range of what, 1 all the way to, from 0 here all the way to 2. So we have 2 here and then 0 here. Then we have 4 minus s squared with respect to x, right? So the area here is just going to be integrating this. We just have 4x here minus s cubed over 3 here. Then we have it's 2 and then 0 here, right? So doing that, we realize that the other part, when we substitute 0 into it, the other part goes away. So we only need this part, right? So we have 4 2 here minus s 2 here cube over 3. Remember, the minus the 0 part, everything that goes away, so we just have 0 for that part. And over here we are going to have 8 here minus, we just have 8 over 3, and computing that, we just have 16 over 3 for the area. So if you have the area, therefore we have to calculate the mass of the particle, right? The mass of the particle as it moves. So now the mass of the particle m here is given by the density of the particle and also the area, right? So if it's given by the density multiplied by the area, then which means that the mass of the particle will just be the density here multiplied by the area. The area here we are 16 over 3, and we'll just leave it this way. Now what are we trying to do? We are trying to calculate the center of mass for the particle as the particle is moving. So we have to calculate also for the movement of the particle as it moves in the s direction, also, and also as it moves in the y direction. So let's do that quickly. So the movement of the particle as it moves in the s direction, so we have to calculate for s direction and also the y direction, right? So let's do for the movement of the s direction, which is given by the density and also the integral from the upper limit to the lower limit, then being multiplied by half here. Then we have the f of s here, d s, remember it is square. This is a general formula for that. So the movement of the particle moving in the s direction is given by the density here, remember from 0 to 2, right? We have half here, and f of s here is just the 4 minus s squared. So we have here 4 minus s squared here, then we square with respect to the x, right? So in doing this, we have mx here, so we have the density still out to here. That now when we integrate this, so let's expand this, it's squared here, so let's expand it first. We are going to get 16, right? 16 minus 8s squared, then plus s to the power 4. That is when we expand that, and dx here. So from here, therefore we can now integrate, right? Or better still, we can now integrate. So we can now integrate. So integrating this, we just have so let's integrate that. we just have half outside. Then integrated system, we just give us 16x. Over here we'll add 1, then we subtract, so we have 8s cube here divided by 3 here. Then s, we add 1 to the exponent here, which is 5, and divide by 5. Then remember the limit is from 2 to 0 also. Right, now the moment of x in the moment of particle in the x direction given by the density, right here, remember we have to, so we just put 2 inside minus that of the 0. Remember, when we put the 0 inside, it's the 0, everything that goes away, so we're only left with this part. So we have half here, then we have into bracket 16, we put 2 inside, 8 here, 2 here, squared, right? So cube, this is cube, then we have 3 here, then we have 2 here to the power 5 divided by 5 here. Now it will be minus the 0 part, right? So the 0 part goes away, and we have the density here. Now when we complete this whole thing, we're just going to get 128 divided by 15 here, and that is basically going to be the particle moving in the x direction, right? So now let's look at it in the y direction. So since we know what the x direction is, what about the y? So let's look at it in the y direction. So the particle in the y direction here is given by it's also given by my here, right? My here being equal to the density here. Then it has the integral from 2 to 0, the lower and upper limit. Then we have x here multiplied by f of x, right? So the f of x in this case is just 4 minus x squared, then the x. So if that is the case, then we have my density here, then we have from 2 to 0. Now let's expand that. So expanding this, we just have 4x here minus s cube the x. Now we can now integrate. So then we have the density here. So integrating this, we just have 4 s squared here divided by 2 minus s to the power 4 here divided by 4 here. Remember, from 2 and then 0, right? Okay, now from here we have the particle in the m direction, in the y direction, the density here. Now over here we're just going to get 2s squared minus s to the power 4 divided by 4 here. Then we have from 2 and also to 0. Now the 0 part goes away, so we are only left with the alright, so we are only left with the 2 part, which is just 2 squared minus 2 here to the power 4 divided by 4, right? Now when we do for the 0 part, it goes away, so what we are left here is just my here. So let's take this away, and therefore we have when we compute this, we just have 4 here multiplied by 2 is 8, and then we have 16 here divided by 4. Then my here will just be the density, 8 here minus 4 here, right? Then my here is just equal to the density, we just have 4 here. Now from here, what we are going to, so over here the coordinate, right, of the center of mass of x, right, and y, right, in the s and y direction. So we have to calculate for the x and also the y direction. In the x direction here is given by the moment of the particle in the x direction divided by the mass of the particle, right? And also y here is also given by the particle moving in the y direction and also the general mass of the particle, right? So we are just going to get mx here, we add ms here to be density of 128 divided by 15 here, right? And here the general mass, remember the general mass here, we had the general mass here to be equal to so this is the general mass from the beginning. We had it from density multiplied by 16 over 3, so we have 16 over 3 here, and then also the my here is just the density of 4 divided by the general one, which is just the density 16 over 3. But remember, this you get rid of that, this also gets rid of that, and therefore we have 128 here divided by 15 here multiplied by 3 divided by 16, and 3 goes into self 1 goes here 5, 16 goes to self 1 goes here 8, and we have 8 over 5 here. And also for here we have 4 here multiplied by 5 over 16. 4 goes into self 1 goes here 4, and we have 5 over 4 here. And therefore we can therefore conclude that the center of mass of the particle, the center of mass is then x, and then y here is therefore given by the x here we had 8 over 5 here, and also the y here is just 5 over 4 here, right? So that will be it, and that will be the center of mass of the particle. Thank you very much for joining me in this section. I hope this section was helpful, and if you are new here, please like, subscribe, and also hit the notification bell so that you'll be notified anytime a new video is posted. Thank you very much, and I'll see you in another section.